Okay, so after we have this part, which is the simplified version of this part, we just have to replace this with this. Or x is equal to plus minus square root of b squared minus 4ac over 4a squared minus b over 2a. So, now since this is division, we can square root the denominator and the numerator separately.
Yeah.
Since we cannot square root the numerator, and we can square root the denominator, we'll just square root the denominator and leave the square root on the numerator. So, at the end of that...
No, that statement was not entirely correct.
Okay.
The statement is you are trying to square root both, and the result is that this square root becomes a 2a, but this square root becomes just as it is. By the way, this doesn't become 2a. What does it become?
2a to the power negative 1.
No.
2a to the power negative
No.
1. Yes.
Again, same mistake. You are square rooting something. What does it become?
Plus minus
Yes,
2a.
plus minus 2a. But why don't we show that plus minus 2a? Because this plus minus 2a really applies. And then if you have, let's say, something like this. Minus 4 over plus 4. Okay? That's a minus 1. Right? You know why that happens even?
Because if you divide 4 by 4,
Yes.
then you get 1, and
Yes.
since there's already negative 1 multiplied by that, it'll be negative 1.
So what the negative is in the denominator. How does it suddenly go in the numerator?
Because we had divided it already.
Look at this. Smart thing. I told you. What does this actually mean? This means actually a negative 1 times a 4. So this means a negative 1 times a negative 1 times a 4. So we're basically cancelling these negatives and remaining this negative on the numerator. See how that happens? So these things are very subtle. No book describes it that way. You have to think about these things sometimes. Okay? That's why if you have a plus minus here, and then also there's a plus minus here, all they're interacting and remaining the same. Because we don't really show it. Okay? Alright, next step. Quick. So next step, I'll write it for you. Or x equals plus minus. This becomes square root of 4a squared square root of b squared minus 4ac minus
b over 2a.
We're already seeing a pattern coming up because the denominator of both fractions will have
2a,
which gives us the leverage of taking a 2a for both and just having a plus minus b squared minus 4ac minus a b. Okay?
which if you rearrange, we come to the equation we want it to be with. Minus b square plus minus square root of b squared minus 4ac over 2a.
Yeah, this is x. So this is the final formula. Okay? What did you notice in here? This is the same thing. Remember we can prove 2 times 2 equals 5.
Yes.
It uses the same thing.
I still have another question. 2a, why did we not use the plus minus in that?
Okay,
Yes.
this one.
Yes.
Look at this. What will happen? So let's say we had a plus minus 2a over a square root plus minus of square root b squared minus 4ac, right? Now what does a plus minus mean? It means either a plus or a minus. How many combinations will we have based on these signs?
We'll have plus plus, minus minus, plus minus, minus plus.
Exactly. So let's start with plus. Square root of b squared minus 4ac. You know what? I'm not going to write the entire thing. Let's say this is x and this is y.
Okay.
Okay? Because we're only dealing with the sign. So first we'll have a plus x and a plus y.
Y.
What should this return to?
Plus.
xy.
Yes, xy.
Okay. Let's do a plus x and a minus y. What will this return you to? Aha. বলো কি হবে?
Minus x and y.
y.
Because, as you've explained up top over there,
Yes, because this is a minus times a minus, becoming a
Yes.
plus. Cancel, cancel, remains a minus. Okay.
Yes.
So you got a plus, you got a minus. Now let's do a minus x and plus y. What is this gonna give you?
minus x
Minus
and y.
x and y. And then we have a minus x and a minus y. What is this gonna give you?
Plus.
So you end up with either having a plus or a minus. That's why this entire thing just remains as it is, and you don't really have to do anything in here. বুঝে গেছে? Okay, great. So that's all you needed to do. Now, the reason why you needed to learn how to derive this is because there are some mathematical underpinnings going inside in here. Right? You've just seen that. An equation that looked initially like this equals 0 now looks like this. Sorry, b squared, no?
Yes.
B squared minus 4ac over 2a is a huge change, and in between you had to deal with a couple of things. One of those things where you had to multiply with the 1 over 2 a. Remember? Is it 1 over 2a? Yes, you had to multiply half of a to make it 2ab, remember? Okay. Also, on the other side, there were things like this 4ac, remember? Okay. When we had this, we also were able to separate. When we had this, we were also able to separate things that became like a b square over 4a square, remember? We had things like this. All these components that you're seeing, if you put them in the graph, you know, do you remember how a quadratic graph looks like?
A parabola.
A quadratic graph looks like a parabola, right? Something like this. So these terms, b square over 4a square, okay, or b square over 4ac even, and things like that. I don't exactly remember, but these things are specific points in the parabola. One of them is the height. Okay, so we needed to learn that there are components in the equation that we can use later, and how they came about in the equation, how they fitted in. One thing that we also realized by doing this, you had to make a whole square, and how this plus minus came because of this whole square and this square rooting, right? Otherwise you wouldn't really remember or know. Now you know. Okay, and because this whole square that you see, there's an implication of a whole square in the graph. It changes if it's a whole square on the side, or let's say a x square, or it's an x cube, or it's an x4. These things will change the graph. So you now know that on the left side of the equation, really you had a whole square of the unknown variable. Mucho. That's important to know also from this. So that's why we need to know about the derivation. Later on, of course, you're not going to derive, right? Okay. Let's stop it here, and then we move on.